Let's take a look at the agent registry work that we've been doing. We'll use as a case study the generate issue description feature, which is the feature where when you go to an issue, you can use AI to, based on a short prompt, create a full issue description. So if we look at our current code, the way that we're doing it is that we have this decentralized, but at the same time, very tightly coupled components where, for example, for generate description, we have a service class and a prompt class. If we take a look at the service class, it has specific references to providers, to parameters. And if we look at the prompt class, we see that our prompts are hard-coded into our Ruby classes. And this poses a lot of challenges. The main one that we're trying to solve here is the fact that if we want to make a change to the prompt, we need to do it here, which means that we need to wait for a new GitLab release to come out with these changes. And in GitLab.com, we deploy very often, but our self-managed customers don't update to every new version. They wait for stable releases. They they update every once in a while. So this is a problem because we cannot deliver prompt improvements for them at the speed that we would like. So the work that we're doing in the agent registry work is moving all of this logic to the AI gateway and implementing a prompt registry which will abstract all of these details, the prompts, the parameters, and even which provider and model we're using, so that we can update all of these things in a way that's completely transparent to all self-managed customers. So this is what that looks like at the moment. We will have an endpoint in the AI gateway for each specific operation. Here, I've already made one for generate description. And one advantage is that the API logic is going to be very simple. Most things are going to be abstracted in the agents. So we have an agent registry where the only thing that we need to do is tell it to fetch a specific agent for a specific use case. So the use case here is generate description, and I created a base agent. The only thing that we need to do is tell the agent, here are the collections of agents that you have access to and what type of agent it is. For example, here's a chat agent and a generate description agent. And for this proof of concept, what we've done is go for a simple approach, which is put everything in a YAML file. I'll talk a little bit about how this might look in the future later. But basically what we're trying to reflect here is the fact that you have now a centralized way to refer to every important detail about the agent behavior that you want to modify. So we have the name, the provider, which is, in this case, we're using Claude, and we have all the prompt templates. And so the advantage with this is that we can make changes here, and all these changes will be contained in the AI gateway, and we can deliver that very rapidly to users. So, for example, if we go back to the running GitLab instance, let's say we want to create an issue description. I already have a short prompt here. Let's say we have a shopping cart application, and we detected a problem that the system charges double if you have 2 items in the shopping cart, something, a simple example. So we can see this working the way it is right now, which is just you give it a prompt, and then it generates a full description for it, which is really cool. But let's say that we now want to deliver an improvement where we always want, I'm just going to make something random here. Let's say we always want to end the prompt with an assign me /command. So we can, for example, change here, only respond with your issue description, and always end the description with the string assign me. So we can make this change. The only thing that we will need to do is restart the AI gateway because we do cache the prompts. This will be equivalent to releasing a new version of the AI gateway using Runway. And when that's running, we should just be able to go back here and regenerate the issue description. And if things go correctly, we should have an updated prompt. So now we see that it ends with assign me. And you can see that I didn't touch the monolith at all. I didn't have to restart the real application. This all happened transparently for the user. And that's just one of the parameters that we can change. But we can also go even beyond and say we can create a new agent. Let's copy this base agent. Let's rename it. And let's say we want to try out an entirely different provider. So let's say we switch to Vertex. So let's now we have a new agent YAML here. Let's say change the name to say this is the Vertex generate description agent with provider Vertex. And let's use model chat Python for this demonstration. We'll leave the same instructions for now. And the only other thing that we have to do is tell the agent registry about this new type of agent. And now this can all happen behind the scenes. And the only thing that the API implementation needs to say is, well, now I don't want to use the base agent. Now I want to use the Vertex agent. And this abstraction is going to allow us to, all the input and output processing is going to stay the same. We just handle in our agent logic all the nuances of changing from a specific provider to another. So if everything goes well, all we should have to do now is restart the gateway again. And try our issue description again. So voila, you can see that Chat Bison seems to be more succinct. But this is, again, this all happened without a single change in the monolith, and even without a single change in our Python code. The only thing that I did in Python was add the new agent to the registry and change the API endpoint to use this. But I think we've achieved a good level of abstraction, and this should help us to, as I said, move forward with prompt changes quickly. It should also enable us to it should also help us to deliver on custom models, because those will also require the specific agents using a specific provider and specific templates. And that's the current state of the Agent Registry PoC. I also wanted to note very quickly how this relates to the work that Eduardo has been doing about using GitLab as a prompt lifecycle manager. And if there's overlap with this, or what's the relationship. And the reality is that this is very synergistic, because this is going to do is replace that a simple YAML implementation that we have right now, and be able to provide us with a much more dynamic backend to retrieve agents. So instead of having these static YAMLs, we could just fetch all the information about the prompts, about the parameters, everything else from a dynamic source, which in this case can be the monolith. So maybe it sounds a little bit weird that we are in the agent registry work taking the prompts out of the monolith, and this seems to be putting them back. But what it's actually doing is putting an interface in the monolith that is not hard-coded, it's dynamic, and we can fetch that from the AI gateway to then return the AI responses to the monolith. So this is all going to work very well together, and this is a very exciting future for the development and functioning of AI in GitLab. Thank you for your attention.